Hello everyone. My name is Deepak. I am from Sri Venkateswara College of Engineering. Today I'll be explaining about the topic called inference using full joint distributions. Like my main topic is inference using full joint distribution, but knowing that we need to cover these three topics, I'll tell you when I teach you. Autonomous agent. Autonomous agents, where it is a real world, where the sensors pass on the signals to model of vehicle location and status, prior knowledge physics of movement, rules of movement, road, reasoning and decision making, action speed, change steering and etc. Where it creates the effectors, accelerator, brakes and steering. Uncertainty in the world model. The agent can never be completely certain about the state of the external world, since there is ambiguity and uncertainty. Why? The sensors have limited precision. Camera have only one many pixels to capture an image. Sensors have limited accuracy. Tachometers estimate velocities are approximate. There are hidden variables that sensors can't see. Example: vehicle behind large truck or storm clouds approaching. The future is unknown and cannot foresee all the possible future outcomes. Rules and uncertainty. Say we have a rule: if toothache, then problem is cavity, but not all patients have toothaches due to cavities. So we could set up rules like if toothache and not gum disease and not filling, and then problem is equal to cavity. This gets complicated. A better method would be if toothache, then problem is cavity with 0.5 probability, or a P of cavity by toothache is 0.8. The probability of cavity is 0.8 given the toothache is all known. True uncertainty with rules are probabilistic in nature, rolling dice, flipping a coin. Laziness. Too hard to determine, exceptional as rules. Takes too much of work to determine all of the relevant factors. Too hard to use the enormous rules that result. Theoretical ignorance. Don't know all the rules. The problem domain has no problem complete theory, medical diagnosis. Practical ignorance. Do know all the rules but haven't collected all relevant but information for that particular. Logics. Logics are characterized by what they commit to as primitives, propositional, facts, and true false unknown, first order, temporal, probability theory, fuzzy. These are all what exists in the world and how the knowledge states are done. Example for this is facts, probability theory. It is degree of belief 0 to 1, degree of truth, degree of belief. Probability theory serves as a formal means for representing and reasoning with uncertainty knowledge of manipulating degrees of belief in a proposition. Utility theory, where every state has a degree of uselessness or utility of the agent, will prefer states with higher utility. The agent is rationally friend only if it chooses the action that yields the highest expected utility, averaged over all the possible outcomes of the action. Decision theory is equal to probability theory plus utility theory. Kolmorov's axioms of probability. 0 is greater than or equal to P of A greater than 1. Probabilities are between 0 and 1 inclusive. P of true is equal to 1. P of false is equal to 0. Probability of I for proposition believed to be absolutely true. Probability believed to be absolutely false. Here P of A P is equal to P of A plus P of B minus P of A B. Probability of two states in sum of 3, which is called the intersection. Here it is called the intersection. Okay, my topic inference using full joint distribution. Starting with the full joint distribution, as you can see this sum, we can solve this. Start with the full joint probability distribution for this toothache. P of toothache is about 0.108 plus 0.10.2 plus 0.10016 plus 0.064 with each 0.2. Instrumentation. Here sort with the probability started probability distribution. Here we have started. We can also compute conditional probabilities like P of not of cavity by toothache is equal to P of not of cavity intersection toothache. Can you see this? Using this formula here we can get as 0.4. Independence. Independence between propositions A and B can be written as P of A by B is equal to P of A. Independence assertions are usually based on knowledge of the domain. As we have seen, they can dramatically reduce the amount of information necessary to specify to the full joint distribution. If the complete set of variables can be divided into independent subsets, then the full joint can be factored into separate joint distribution on the subsets. For example, the full joint distribution on that where the independent coin flips P of C1 to P of C1 can be done in the product of n single variable distributions P of. As you can see, there is a P of xy be a random pair of variables. There is joint probability P of x equal to y, x and y is equal to y. The first probability that variable x will be taken on the value of x and variable y will be on the value of y. Conditional probability is the probability that a random variable will take on the particular value given that the outcome for another random variable is known. For example, the conditional probability P y of y is equal to y and x by x refers the probability that a variable y will be taken on the value y given that the variable x is observed over the value of x. The joint and conditional probabilities for x and y are related in the following way. P of x by y is equal to P of a y by x. P of x is equal to P of x by y. By arranging it, we will get this formula. This is all called the Bayes theorem, which I explained earlier. Okay, Bayes laws where these two conditions or these three conditions are taken into account to get this Bayes theorem. P of b by a is equal to P of a by b. P of b, P of a, P means probability. Bayes law also Bayes law or Bayes rule is fundamental to probabilistic reasoning in AI. Thank you. Please like my video.